Hello, everyone. We're live. Today we have Aishwarya Srinivasan, and I'm very excited to have her here join me in this talk. And we have about 37 people here, and let's maybe wait for another minute. Um, Tell us where you are in the world, and we also have some polls. You can tell us what are some of your experiences with large language models and Gen AI. Hi, Rishu. All right, I think maybe we can get started. Hi, Chinmay from New York. Um, we have folks from all over the world, so that's very exciting. Okay. Um, You probably already know Aishwarya from LinkedIn, and if you don't know her, she previously worked as a data scientist on the Google Cloud AI services team. She built machine learning solutions for customer use cases. And previously, she was a data scientist at IBM. She holds a postgraduate in data science from Columbia University, and she has over 400,000 followers on LinkedIn talking about data science and AI. She has been spotlighted as the LinkedIn Top Voice 2020 for data science influencers and recognized as a woman in AI trailblazer. Welcome to ML Real Talk.
Thanks a lot, Daliana. I should definitely say I'm very impressed with how you pronounced my name correctly.
I definitely have practiced.
Not just the first name, but the last name as well. So thank you so much for that. And yeah, I'm super excited to join you on this talk. I know that you're like from the similar background as well, and you've been working a lot in the side of like generative AI. So I'm very excited to have this conversation. And with everyone, this is going to be a two-way conversation. Like Dalian and I are gonna both be talking about our experiences with generative AI. So very excited about it. And if you have any questions, please feel free to add that in the chat.
Yeah, so um, let's get started. So you probably have heard of a lot of buzz about generative AI. So today we're going to talk about what does it mean for data scientists, especially how do we build responsible AI solutions. Um, and maybe before we get to it, Aishwarya, can you give us maybe a quick introduction of what is generative AI and what is the power and potential of it?
Yes, absolutely. I'm just going to quickly share my screen. And just to make sure that people here are going to be from different backgrounds and different practice areas, so I just wanted to give a very very brief introduction about what generative AI is in case somebody is new to the field. So in a nutshell, the way I would put generative AI is any kind of model that is able to produce content. Now this content can be in form of text, it could be in form of images, it could be in form of code, it could be in form of audio, whatever it might be. If any model is able to produce content out of the fly, that's what is a generative AI model. Now, there is obviously like terms in that is used interchangeably. Large language models and generative AI is something that is used interchangeably, but it's not exactly the same. There are overlapping factors around it, but it isn't exactly the same. A large language model is trained on text data, and it is used to generate text data or work with text data. Now, not all the time a large language model is generative in nature. Of course, what we see with ChatGPT or Bard is generative in nature because it is producing text out of the fly. But large language model is also used for other purposes like topic modeling or classification, which isn't generative in nature, but still needs the capabilities from a large model. So that's a like quick introduction about what is generative AI, and I've just added some examples. If you're new to the field, definitely recommend you try it out. I'm sure most of you would have tried out either ChatGPT or Bard, so you have an idea on what the look and feel of it is like.
Yeah.
I can just quickly go to the next slide, Daliana, addressing your question, right? Like the part where we were talking about what is the power or what is the use of generative AI in the current era that we are living in. I have just tried to keep it as quick and as important as I can put in one slide. So we have obviously seen the impact of generative AI in creative field. So a lot of artists, a lot of musicians, or a lot of people who are working in that creative space have leveraged generative AI and tried to produce a lot of new content. We have seen a lot of people who are into fiction writing or who are into blogging also use generative AI in their assistance. At the same time, we have seen generative AI models which have gotten into organizations and started helping organizational workflows. So a bunch of the use cases that I've seen which are very prominent are around document search, are around chatbots, which organizations are now using in order to ease out their process that they have in place. And obviously another part which is more of a hardware side or like robotic side is also one of the places where we're using generative AI in order to make the processes more precise and in order to avoid any kind of like human error that might come in that particular process.
Yeah, thanks for helping us understanding those concepts. So I think uh, at this point, we're probably all users of generative AI products, especially the first one you mentioned. We have seen a lot of AI generated artworks. And I think when you generate arts, you want a model to be creative. So there's not much concerns about a model hallucination, but there are different type of concerns. For example, where do we get those images to train their model? So if we generate a style that's very similar to artists, um, are there any like legal concerns? So um, I think on one side it definitely democratize art creation, but on the other side artists feel they've been taken advantage of.
Yeah.
So from the perspective of a builder in AI, what do you think about this, and how do you think we can address those ethical concerns?
So Daliana, you have brought up a very, very interesting and important point which people who are on the engineering side or people who are in the data science side oftentimes do not pay too much attention to. So back around like start of the year, I had actually put out a video. It obviously doesn't have anything to do with a particular product, but that video where I was talking about Lensa AI, because that's the product that I tried out at that point in time. And I had put a review about like, what are the issues that I see in that particular product. And it wasn't, again, like it's not about the product or about the company, it is just about the tooling or like how they're using that generative AI model. So two major concerns that I felt during that particular process is one, I had used my images and I had shared it with the app, and it was producing more images like me in different backgrounds, in different haircuts, in different clothing, etc. So one of the major concerns that I had is, one, where is this data coming from that they are training these models from, right? Is it consented by the artists or the people who have put this out? Like, is there any kind of copyright issues that they have on the data that they have trained? Second thing is, how are they saving my data? Because this is personal information, right?
Right.
Whenever we are using a social media like Facebook or Instagram or Snapchat, anything, there are underlying terms and conditions that we are accepting to, where we say that any of the data that I'm putting on Facebook or on Instagram is going to stay public on the internet. But it's very different on how you're going to use it with these kind of applications, because obviously they cannot put it public, but at the same time, because you're using generative AI models, there is too much power in their hands on what they can do with it. And one of that use case is pornography. If you were to put one particular picture of one person and you're trying to extrapolate that and produce thousands of more images, that's a critical risk that we see in that place.
Mm.
Now, third problem that I felt in my personal case was also very weird and very interesting at the same time. So the image that I had put, I have a slightly darker skin tone. So the images that I had put, the produced images were changing my ethnicity.
Mm.
So the produced pictures were showing as if I am ethnically black. And then those were the pictures that it was showing with different kind of hair than what I have, with different eyes or with different facial features than what
Yeah.
I have. So that was really concerning to me because it made me realize that maybe Indian or Asian is not in the data set that they're training their model in. And that's the reason that it's not identifying my race based on my picture, and it's extrapolating my facial features to a completely different race.
Yeah.
So that was another like alarming issue that I found. I've also like gotten deeper into these issues in that video, but overall, like few of the things that I felt was these biases that we're talking about, right? Like what is the data that they're using to train these model on? Has it been consented by these artists whose information is now being sent to a model and reproduced in different ways? What does the privacy look like? What are the things that they have put in place? Like does it which laws does it have to abide by? Right now we don't really have any policies or any legal ways to ensure that it is private. EU AI Act is coming up, but it isn't
Mhm.
really emphasized right now. And the third part is around misuse, right? Like there are various different ways that I can think about on how these generative AI model can be misused, introduce misinformation, and can have ethical concerns addressing to who the users are.
Yeah. Yeah, thanks for sharing the example. So when we look at those concerns, what are some metrics we can use? For example, in terms of data collection, how do we make sure the data set is diverse enough? And also during the training, how do we, make sure the model is not biased, and then what kind of process? I think for different, I think this is a difficult question because for different product, there are different type of focus, and different companies or have a different policy. But in general, say if you are going to build a Gen AI product, what would be the process you follow from data collection, training to putting model in production?
So that's a very interesting question that you're raising, Daliana. And there are a lot of pieces of this puzzle which is very subjective. So things around model monitoring or keeping a track on how well the model is doing and it doesn't get stale over time or it's robust, probably we have good metric to measure that. But when it comes to metrics like, is it fair enough? Is the data set diverse enough? These are things which are still a point of research, and a lot of universities are still working on how to really quantify these metrics.
Yeah.
So there isn't like one right answer for this at this point in time. But I'll just like share an interesting thing that I learned. So a couple of months ago, I did a course at Stanford, and the professor that I was learning from, he is researching in this responsible AI space. And one of the things that they are working on, so there are institutes like Stanford, there are like multiple different institutes, and even there is a specific entity called Responsible AI Institute, which is also focusing on this area of research. So one of the things, like when this discussion came up during one of our lectures, so the professor was pointing out that, when we are training large language models, we want to make sure that it is fair or it is not biased. And one of the examples that he had on his slide is, um, Dash was a doctor, or Dash is a doctor. And he said that when we ask the model to fill in the blank, it should not be gender biased, which is fair. Like that's how we are measuring that this model is fair, because it's not stereotyping that a doctor should be a male or a female or whoever, whatever like a fluid gender they might have. But at the same time, there are certain stereotypes. I wouldn't call it stereotypes, but there are certain features which are prominent for certain classes of humans, or certain classes of whatever it might be, machines, or like, certain class of categories that we're looking at. For example, if I were to talk about, if I'm particularly talking about, let me put it this way. So let's say I have certain terms like skirts, or let's say I have certain terms like um what do I let's say there's something specific to, like, periods, or like there's some certain terms which are very specific to a particular gender.
Mm.
You also want to make sure that the model is able to identify that correctly. So the hallucination or the bias should not be working in a way where it neutralizes everything. We not only do we need to make sure that it is not stereotyping, but at the same time we want to make sure that it is not over neutralizing any kind of differentiation that we have between different categories of people, or different categories of things.
Mm.
So that's a very tricky area of how do you quantify it. It's a
Yeah.
very, very subjective and qualitative way that you have to think about it. So that's an active area of research, and there are different metrics which partially covers these things, which have been released open source by universities and like research organizations, but there is no like one stop solution for any of these.
Yeah, I think that's a great example. I also noticed, for example, in a recent launch of Llama 2, they are, a lot of mentions on how they take kind of AI safety into consideration. And I was looking at a paper, they also added pronouns
Mhm.
when they train the model. And there's also an example if you ask the model to I think something like a rob a bank or something, the model will tell you no.
Yeah.
But like you mentioned, I think it's really hard to quantify. I think that's why we need to fine tune models on our own data because every use case is different.
Yeah.
Because I would imagine if you have a model that's, um, you know, kind of very safe, it's probably less creative. It might not be able to generate a lot of, say, writing or those type of tasks.
Yeah.
And if you have a, kind of vice versa, it depends on what you want the model to do. And also, I think the adding of pronouns is interesting because if you ask different groups holding different, could be political beliefs or beliefs about gender, they could label the data in a completely different way. And then the output of the model will also be different. And as a user of those generative AI products, and you might also get subtly influenced by the model. And then I think those might also um, filtered into your political beliefs. So what do you think about this?
100% right. And that's where it's kind of tricky on what you want your model to do and say in situations like these. Because at one hand, you want it to be creative, you want it to be open, you want it to be learning, but at the same time, you don't want it to re emphasize any kind of biases or issues that are present in the society already. So it's definitely tricky, and I'm still, like, I'm still following the research on my end, like following these institutes, like following like this course was also um, a part of the process, because it was important for me to see what the universities are doing at this point in time, what are the areas that they are working on.
Yeah. Um, So I see some questions in the chat. We'll answer some questions later, maybe the last 15 or 20 minutes.
Mhm.
What are some more, do you have some examples of some specific metrics? For example, when we're training on like offline data, what are some metrics um, we should use when it comes to evaluating model transparency and fairness?
So I can talk about some of the ones which have been applicable for general machine learning models before I move on to specific to like generative AI. So, with respect to a general machine learning model, there are various different things that you can put in place to ensure that it's robust, right? In the end, that's what you want, that your model is robust and it's performing in the right way that it was built for. So, metrics that you can use, and unfortunately, I don't see it being used as much, but I definitely advocate for it being used more, is things like data cards or tracking data lineage, tracking any kind of cataloging that helps us understand where is this data coming from, and if there are any kind of like pre-processing that has been done on the data or not. So one of the major challenges that I've seen with a lot of companies is that they are replicating, duplicating data n number of times. There are different versions of the same data that's available with different people and who are working in silos. And that's one of the issues that comes when you are not tracking where is the data coming from and what are the updates that have been made on the data. So that's one important part that I would start with, right? When you're starting with data, make sure that you have accountability, you have documentation, you have cataloging of where your data is coming from, and you're tracking the lineage of the data.
Mm.
Also, at the same time, there are data validation techniques that is also well researched. There are multiple tools that are available right now, open source and proprietary, that will help you identify if there are any issues with the data. It can be minor issues, which could be around duplication, it could be around skewness or like sparsity in the data, etc. But it could also give you higher insights around the topic that you just mentioned, which was around diversity, right? You asked about how do you understand if the data is diverse enough or not. So one of the factors in data, in measuring that, is called cardinality, where you try to understand how many different categories of a particular feature do we have in our data set. So when you are doing this data validation step well in advance, even before getting into the model design part, you can address these concerns initially, because you see that the cardinality of that particular data set is low, or that particular feature is low. Then it brings back the question on how do you improve this diversity issue in your data.
Yeah.
Following that, I believe the other parts that are in place is around model tracking as well. So how do you document your models? How do you account for what are the different versions of the models? What are the different kinds of training data set that you've used for that model? What are the different kinds of parameters that you're using for that model? This is also important because from an accountability perspective or an auditing perspective, it is important that somebody is able to track how you have built the model and what is the intention of the model.
Mm.
Also, subpar covers the transparency part, because you want to ensure that any of the parameters that is going into the model accounts for parameters that should go inside the model and doesn't have features like caste, race, gender. These are like the typical concerning issues that we have with the model. So when you have model documentation and model cataloging, this also comes in picture. Then obviously the other part of the puzzle, when you're looking at advanced or like matured MLOps pipeline, is around monitoring and training. So again, depending on which model we are using, there are different methods of how do you monitor and retrain the model or keep it up to date. But yeah, that's another like section of the puzzle.
Mm-hmm. Yeah. Yeah, thanks for sharing those metrics. So previously you mentioned the EU AI policy a couple of times. Can you tell us a little bit about what is it? And before we dive into it, I also have a question. I talked to someone else from Germany recently, and he told me basically it's very hard to train large language models in Europe because they're very strict about what data you want to use. I think on one side, it's good for citizens to protect their privacy, but on the other side, their tech development is significantly slower compared to the US. So maybe can you tell us a little bit about what does this AI policy do, and what do you think about what does it mean, kind of both for us as a citizen, and also what does it mean for tech practitioners?
Yes, absolutely. I am definitely an advocate for these kind of policies that should be in place, because I believe it's better to be safe than sorry. And at the time where I really appreciate that everything that we're doing here, which accelerates the innovation, but at the same time, there has to be a balance on
Yeah.
how do you ensure it doesn't go in the hands of wrong people or get used in wrong forms. Because I mean, like, I don't think I have to explain, but as soon as ChatGPT came out, you saw how many millions of people started using it right off the bat.
Mm.
And that is great and concerning at the same time, because if we are releasing any premature products or things which have not been tested out well before it being released to such a huge number of audience, then it can cause detrimental damage. So I definitely advocate for the policies that EU has been working on. Like, I have made videos and like posts about this in the past. Like, 2021 I wrote a lot about it when I was talking about like the data privacy policies, the federated learning research that is going on, and how that will help us build like better machine learning models. But to your point, like, I've just concisely mentioned some of the things that I found was really really important, and highlights from the UAI bill. Again, this is not an exhaustive list. There's so many more things that they have mentioned in the UAI bill, but these are the highlights which I thought was overlapping to what are the changes with respect to generative AI. So UAI is not just about the generative AI models, it is about any AI model or anything that uses any model whatsoever. It's not just machine learning models, it even calls out for statistical models.
Mm.
I just wanted to highlight some of the things which are also very relevant from a generative AI perspective. So, first things first, like copyright, right? Like, copyright is something which is super, super important, where we have to understand and regulate how the training data of these models are coming from. So, one of the common things that people have started doing is hashtag no AI. So, any of the metadata of a piece of information which is lying on the internet, be it text, be it image, be it audio, if that contains a metadata of hashtag no AI, that means the author of that particular content is not allowing an AI to be trained on that data. If it's not a consented data, then the model should not be trained on that data. So that's one thing to start with. Second part is, once you are producing any data out of AI, so basically if you're using ChatGPT or Bard, or if you're using any kind of like image generation model to generate images, you cannot copyright that information whatsoever. And this is something which did not happen until very recently, because there were posts that I saw online which said that people had generated like children's book, and people had like copyrighted that book because they used some of their ideas, they put it through ChatGPT, and ChatGPT produced a children's story. They just copied that script, published a book, and within 2 weeks they were an author. So that was concerning, because now you are taking away the creativity from a human generated content, and maybe underlying content is coming from somebody else's idea, which is now being copyrighted by this particular person, and this is a never ending loop. So that's one of the things that has been strictly mentioned in the UAI bill, that any content which is generated by AI in any form cannot be copyrighted. The second thing that EUAI bill also focuses on is, um, they have categorized different kinds of applications in high risk, medium risk, and low risk. So I'm not going to get into details of it, but the high risk applications, which has anything to do with common people using these applications, are categorized in high risk. And these applications have to have gone through certain kinds of assessments and checks, which helps us understand that they are safe to use. They are transparent, like there is a process in place to audit these models. There are processes in place to check quantitatively about how the model is performing at any given point in time. And if they are using anything like facial recognition, then it has to go through higher security checks. So that's another thing that is being introduced in new AI bill. And the other thing is unacceptable AI. It's a very interesting term how they have put it right there. Is things that should not be accessible to humans or that should not be tested over humans. So
Mm.
one of the things that they have mentioned specifically in that bill is things like social scoring systems, or using any kind of system that is able to use public cameras to record you and collect information about you without your consent. And there is an interesting use case. I'm not sure which TV series this was in, but I saw this in one of the documentaries where they were using public cameras to identify criminals. So
Mm.
they were able to like track all possible public cameras, and they were able to identify if there is a most wanted criminal that's on in their database. They were trying to match the facial recognition features and identify if they are seen in any of the public cameras. Something like that is not allowed now, because it poses risks on people who are not coming from that particular category. So it should not be a case that people who are not who should not be victimized because of this particular technology. And obviously some of the other things that I've mentioned here is some things that you might have heard of, with respect to transparency, with respect to having human oversight, especially for generative AI models. It is really really critical to have some kind of a human insight, and that's where we have started learning more about reinforcement learning using human feedback, so that we have a continuous check on these models. And yeah, like rest of the things I've just blanket mentioned here. If this is of your interest, definitely highly recommend that you go read that bill. It's really 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 insightful, and there is a lot more details that I couldn't mention in today's session. But the part that I spoke about, like how are they categorizing the high risk, low risk, and medium risk
Yeah.
entities in AI.
Awesome. So it sounds like there's a lot to unpack in the EU AI bill. I think reading it, it helps us to understand kind of understand more about what are the concerns there, even if it doesn't apply to us immediately. I think it help us just be aware of those things when it comes to training our own models. So when it comes to generative AI, besides those use cases on art or like chatbot like ChatGPT, what are some other use cases? Do you have some examples, especially those ones related to data scientists day to day?
Yes, I did have one on the document search. So So I just wanted to mention document search because this is something which people might have tried using tools like LangChain to produce it, and it is a pretty prominent use case with respect to industries as well. So I just wanted to like briefly talk about what could be some of the potential risks that you need to ensure when you're working on these models. So document search, as the name suggests, means that you have a bunch of documents. It could be in PDF forms, HTML forms, it could be structured, unstructured, but you need to search and find certain things from these documents. So at this point in time, what approach that you are likely going to take is use a large language model and store these data set through a vector database, create those embeddings, and then go ahead with the language search on top of it. But when you're doing that, there are certain risks that come in picture. One of the things that we have been mentioning a few times over this call is about hallucination, right? How do you ensure that the answers that you're getting out of these searches are not hallucinated, are actually real? And one of the solutions for that companies have been using is to tie it back with factuality. Now factuality is sounds fancy word, but it is a pretty simple on the back end. What you're using as a prompt with your large language model is asking the model on where is that embedding, and what is that data that is associated with that embedding, from where you are extracting those words. So if you force the model to go search for that embedding, and if it doesn't search for is not able to search for an embedding where that answer exists, then it's not going to return you back anything. So that forces the model to only return answers which are tied back to factuality, and it is able to give a particular reference that this is the answer to your query, and these are the two or three sources from where I extracted that particular information. So that's one part where you're forcing the model to tie it back to factuality to ensure that it is not hallucinating for critical use cases. And this also like accounts for any kind of fairness, right? Like when you're trying to make sure that your model is not returning any kind of information which is unfair, you have to train the model, you have to give it prompts with which it understands that what are the things that it should and should not include in the responses that it is producing. For example, very critical example, that I'd come across recently is that this is a very tricky part. There is a part about access management, right? Things that I should be having access to may not be things that you should have access to. So if I have access to the document search and you have access to the document search, then how do you control the output that I can see versus the output that you can see?
Mm.
So that's another like area where you need to have checks ensured on what are the things that you have access to versus what are the things that you don't have access to. And entailing to that, like you have to understand that any kind of like information that the model is producing doesn't have any kind of biases introduced in it. So that is also partially solved based on factuality. And the way it gets solved is if there is indeed any kind of biases that exists because there are information that exists in your database that accounts for it, then that comes up to the surface. So that's one of the use cases that I wanted to talk about and sort of like tie it to what are the issues and risks that are potentially there in these use cases.
Cool. Um, so I think that's all the questions I have today. Definitely want to dive into Q&A. So are there anything because we talk about generative AI use case, I think another one is code generation. We actually have a quick demo. I want to show you how to generate code. Is there anything else you want to add before that?
I think we've covered pretty much all the points, so happy to like dive into the questions now.
Oh, okay. Yeah. So maybe we'll do the talk about the code generation and then we can dive into
Yeah,
questions. Okay,
sounds good.
sounds good. So we have our engineer from our Prady-based team. Arnav, do you want to showcase how do we do code generation?
Yeah, absolutely. Cool. So maybe I can share my screen window. Okay, let's do this. Let me know if you're able to see my screen, and then happy to walk through things. Is it visible?
Yeah,
Not
I
yet.
can see it.
Okay, yeah, sorry. Thanks for confirming. So, um, for those of you who aren't familiar with Predabase or haven't heard of it before, um, so essentially, it's a platform where you can fine tune and deploy LLMs anywhere from 7 billion parameters up to 70 billion parameters. And one of the things, since we're on the topic of, um, you know, what can we do with LLMs? I think one of the really good ones is code generation. And there's been a lot of different models around this, from like Code Llama, which is the most recent one that Meta released. But what I thought I could demo through Predabase today is how do you take a base model like Llama 2 and then fine tune it for your task, in this case, code generation. And so what you see here is a snapshot of the Predabase platform when you first sign in. You see that there's something called the Python SDK, which I'll walk you through in a moment, and a couple of quick start guides. And there's two ways you can interact with the Predabase platform, the UI and the SDK. I think maybe the cleanest, just in the interest of time, is to go dive into the SDK first, and I can then quickly also show you how you could do the same thing through the UI. But both flows work, and so it's depending on whatever you're most familiar with. And so broadly, in like 8 real lines of like Predabase code, you can go from a deployed model to querying it to fine tuning it.
Oh, sorry. Could you give us maybe a high level of what the script does and then what kind of code that we generate
Yeah,
today?
yeah, absolutely. So let's maybe dive in a little bit further. So the goal today is essentially given an instruction in natural language, we want the model, like when we prompt the model with natural language, we want it to return a functional piece of code. So if you say, this is like a pretty simple one, create an array of length 15 containing numbers divisible by 3 up to 45. We wanted to return, this array, for example, right? And that's like a valid output that solves the problem. Now, obviously, this is only valid in Python, but you can also specify that in the instruction. There's also this column of like an input column where sometimes like the instruction is like a high level instruction, like this one, write a function to find the number of distinct states in a given matrix. And then we give it like an actual input. And then we say, now, maybe solve for this specific input, write something general that works for all inputs. And so this sort of like approach to fine tuning is called instruction fine tuning. And it's pretty much why ChatGPT works the way it does, where they've taken a base model and fine-tuned it on all of these different instructions and outputs or expected outputs. And then the model learns to respond or follow these instructions. So we're going to do the same thing for code generation. And so I'll walk you through what that might look like and why this is even necessary to do. The first step is actually to install the Prabas SDK. It's as simple as pip install Prabas. And then you want to sign in and use your API so that whenever you launch any training jobs, all of that is done through Prabas Compute. So that way you don't have, I'm using Colab, but the training is actually happening on Prabas. You set up your Prabas client from which you sort of launch all of your tasks. So let's do a couple of different things. Let's deploy Llama. So what I did actually pretty much 30 minutes before this webinar is I decided to deploy Llama 2.7 billion, which is one of the, I guess, like recently most popular open source LLMs that is shown to have like really, really strong performance, even at the 7 billion parameter level. And so in Prabas, you just have to do pc.llm, specifying what LLM you want to deploy, and then say llm.deploy. And you can give it a custom name. And then Prabas at the back will spin up like a highly optimized inference engine for you to then make queries against the Llama 2 base model. So the next thing I decided was to see, let's actually prompt this model with the code generation task. So a pretty common way of doing this is by describing the instruction at length. So here I say below is an instruction that describes the task, and then you might have an input that's paired with it. Write a response that completes the request. I could have been more specific to say, here's an instruction to generate code, write code that works. That would also work. But this is actually a pretty common general template so that you don't skew it too much. And I basically just say, get the same LLM that we deployed and then say LLM deployment.prompt. So again, just 2 function calls to actually prompt the model. And if we take a look at the output, you can see that it looks like it's producing valid Java code to reverse words. It's functionally got the right signature, but then it does what all base models do. It starts I won't call it hallucinate, but it doesn't know when to stop. So it repeats the instruction, produces the code again, repeats the instruction. And if I made this 512 tokens, you'd see this pattern just continue to repeat. So you can see that the models are good at their base level, but are not just the output that we'd want. Like in an ideal world, for a code generation model, think, Copilot, you just want the right code to show up. So this is a good enough indication that maybe fine tuning is a good way to go. And so let's say we want to fine tune this base Llama 2 deployment that we have with our data. I actually uploaded a small snapshot of 800 rows of this data set called the Code Alpaca data set, which is what I showed you right here. This has a set of instructions, inputs, optional inputs, and outputs. And then all you need to do to launch a training job on Prabas is upload your data set. Prabas supports, file uploads, but even, if you're an enterprise, S3 or Delta Lake or Snowflake, you can choose where your data lives. So you just have to upload your data set or grab it from there. You can define the same prompt template. you can pick your base model as we've been doing, and then just do an llm.fine-tune call. So it's as simple as that. You pass in your template, you pass in the data set, and you say the target that we want to predict is the output, which is the column that's coming from the data set. And that's about it. So what this does is it launches a training job. It uploads your data set. It shows you the compute that Predabase uses under the hood. So in this case, a G4DN 2x large, which is actually just a single T4 GPU, probably the cheapest GPU that you can get on enterprise. And it starts fine tuning. So I don't know why the Colab printout was kind of strange, but what it does is it shows you the training steps, the number of epochs. So we're fine tuning for 3 epochs by default. And Predabase chooses a lot of smart defaults for you under the surface. So it makes it really easy to fine tune. You don't have to do anything else. And you can see it prints out a set of metrics for you, pretty in-depth sort of metric profile. Trains for a while, so it took about 26 minutes to train, and then the model was ready. So fine tuning was very simple through like the SDK interface, but the real question always is, does fine tuning help, and what does that look like? So what I did is Predabase supports 2 different ways of running inference post fine tuning. The first is real-time inference. So you can think about this as like a chat setting where it's more useful, or batch inference where you're building like recommender systems that are not running in real time. So it's again very simple. You deploy your model, the model you just fine-tuned, and you call fine-tuned llm.prompt, pass in the same prompt again, and you'll see that this time it actually produces just the function signature, when this actually is correct code as well. So it basically splits the string, iterates through the words from backwards to the beginning, appends them, and then returns it. So very cool that this works post fine-tuning, and you can see it's very concise in its output. So pretty cool that just 30 minutes of fine-tuning gets you to this level on 800 rows of data. And then Predabase also exposes this batch inference version. The same idea, but you can pass an entire data frame, and it'll return all the results in like a list or a data frame back to you. So that's a high-level idea of like how taking a base model and fine-tuning it can actually really help it do really well on these domain-specific tasks, because base models are very generalized. And how Predabase SDK in particular, that basically abstracts away all the complexities of fine-tuning, so that basically through 4 or 5 major function calls, you can fine-tune, deploy, and then test your fine-tuned deployed model in a very quick and easy way. Finally, the last 30 seconds is that through the UI, you can do the same thing. So I know Aishwarya was talking about code organization, tracking experiments, tracking the data that was used. Predabase actually makes this really, really nice and easy. So you can go to this model builder that we have, select your, build a custom model. You can pick your data set in which you can upload to the UI or the SDK, pick large language models, and then hit next. This actually brings you into the model builder, where you can choose, from a set of preset models. So, there's a bunch that we support, including Llama 270 billion or custom. So any model on Hugging Face, you can define your template, you can define your task. Here you can actually control all of the parameters. So, pre-processing, let's say you want to choose how the value should get split, or how many tokens to use, or capitalization, things like that. And then it's as simple. And by the way, we pick all of these defaults for you anyway out of the box, and you just hit train, and that's it. It launches a fresh training job that will train this model in the same way that the SDK trained it, and produce the same charts. So yeah, whatever you're comfortable with, but just wanted to just show you that fine-tuning does help a lot and can be made very easy if you'd like it to be.
Yeah, thanks for the demo, Anarp. Are you able to share the Google Collab with us?
Yeah, absolutely.
Okay.
I just have to hide my API token, but I'll share it out.
Yeah, gotcha. If you registered, so maybe we can send a follow-up email, or maybe we'll publish in a blog post. So let's bring back, thank you again, Anar, for the demo. Let's bring back Aishwarya. I know you have a hard stop at 10, you're giving another talk. So let's answer some questions.
Yes.
So I'm not gonna pick by, the kind of who asked the first or later. I'm going to pick a few we
Sure.
haven't addressed. I think this one Kimberly asked is a good question. So you mentioned the no AI hashtag. How does it work on the technical side, and how does it work compared to the don't crawl type of code?
So it's very similar. The don't crawl type of code. So there are different, like I believe, like 2 or 3 different ways of how you can track this. So certain websites have this page called robot.txt, which basically says that if that particular page should be or should not be crawled. So that is one of the ways that you can check if any of the content in in that page can or cannot be crawled. But at the same time, when you are crawling any particular page, all of these images are being crawled from different kinds of websites, right? So when you're crawling that information, you're also extracting certain metadata with that particular website, so which includes image, the title of the image, and any other metadata that comes with the image. So that is where you can see these, like a hashtag no AI. Again, it's not a widely used hashtag, or it's not a widely used metadata, but now it's being propagated, it's being advocated for that you should be using these kind of hashtags, so that companies or who are building these models know that your data should not be crawled.
Yeah. Yeah, thanks for the answer. And then Vinay asked about hallucination. How do we check the results if it's due to hallucination or not? Maybe I can share a few of my ideas, and then curious to see what you think. So from a kind of metrics perspective, I know if you have control of this model, for example, if an open source model you fine tuned, it's kind of you are able to see, or if you're able to see the output probability of the answer, you can just look at whether the probability is the score is high or low. If it's low, that means it has less confidence in it. But a lot of times we don't have access to those probability. For example, if you use open AI model, it doesn't tell you the token level probability. So what you can do is you can use a couple of large language models and you compare to see what are the consensus. So basically you're building an ensemble of the large language models, and then if one significantly kind of disagrees with the rest, so this one might be hallucination. I think it depends on the type of models you use. I think some people call this like black box, gray box, glass box solution. Yeah, curious. What do you think?
Actually, yeah, you nailed it right. That one of the things that you can do is, like, there's a factor called temperature. That's what you're mentioning about. So temperature is basically telling the model how much can it be flexible on the probability number that it can use. So there is actually a very nice visualization. I wish I can pull it up right now, but it might take a few minutes. So there's a very good visualization that talks about like how temperature works in large language models. Temperature is basically a factor that using which you're telling the model that how much creative it can be. So if you set the temperature as 0, which means that it is going to pick the highest probable word in its next word prediction list. But if you set the temperature to be high, then what it does is it essentially shuffles between the next 100 words that is probable. So basically you have a list that says that the next probable word is cat with a probability percentage 0.98. The next probable word is rabbit with the probability of 0.7. The next word is giraffe with the probability of 0.3. So if you set the temperature to be low, then it's only going to pick the ones which have high probability. Versus if you set the temperature high, then it's going to make the model select words that can come in lower probability as well. That's where you can control the creativity of the hallucination of the model. So a metric that you can use to measure hallucination is subjective. You cannot really, based on the answers, there are like, for 100 different questions you'll get 100 different answers. So there is no way to measure the output hallucinations. But what you could do as a measure is the factuality part that I was mentioning earlier. You can provide specific prompts to the model which ensures that it is grounded to factuality, and it ensures that it ties back to a piece in your data set, and it is able to pull out that piece of text in your data set which from where it's getting that particular answer.
Okay, great. And then maybe this is the last question. So what are, Rishu asked, what are some factors to consider on the data governance side when using open source libraries for LLM frameworks? Are they generally safe to use at the enterprise level? So I think if you work for a company, I guess maybe one step further, what are some process you go evaluate those open source libraries?
I feel open source libraries are easier to evaluate because you have the flexibility to see how the model works, and you have the flexibility to try it multiple times and try to make it fail for situations that you want to test it for, which is not the same with proprietary models. But what I've also observed in the last year or so is that any model that is really, really good has been made closed. So
Mm.
that was the case even with OpenAI, that we saw that they came out with really good GPT-2 models and GPT-3 models, and after a point they stopped making them open. They started making them proprietary. So that's what has been happening. Like Llama 2 is probably an exception, which is a really good model and is open source. So I would say it's more flexible if you're using open source model because you have more control over the model. But if performance is a hindrance, if you feel that proprietary models, the performance is better, or if companies are looking for managed solutions where they don't have to think about infrastructure, they don't have to think about the pipelines, then proprietary might be a better choice.
Mm. Thanks for answering the question. Before we wrap up, is there anything you would like to share? Where can people find you online? Any upcoming events you want to give a shout out?
Yeah, in another like 10 minutes I'm going to be speaking at GHC, so that's why we're sort of like rushing this through. Apologies on that. But yeah, I'm very active on LinkedIn, so you can always reach out to me on LinkedIn. That's the best platform to reach out to me. And yeah, in case you want to in case you want to share some thoughts or you have any questions regarding what we spoke today, I think Daliana, if you have any other way that people can send these questions to you, that's I'm happy to answer them offline as well.
Thank you. I think this one will be this video will be recorded. I think Michael
Okay.
later will share with the audience.
Amazing.
This is a great talk. I learned a lot from our conversation. I also really appreciate the questions asked from the audience. We also have more ML Real Talks coming in the future. And make sure you follow our channel. And looking forward to see you in future events. And thanks again, Aishwarya. Good luck in your next talk.
Thanks, Daliana. Thank you everyone for tuning in.